Welcome everyone to this keynote session. We are very grateful to our sponsors who make this conference possible. Before today's keynote by Jeroen Ooms, we have a 5-minute presentation by Roche, our sponsor of the day.
Hello, my name is Jeroen and I work as a data scientist at Roche, and I'm happy to talk to you about how we leverage interactivity in our clinical trial work. It's actually exciting times to work as a R developer at Roche because we start to use R more and more across our whole content delivery process, starting with exploratory data analysis for basic research, diagnostics, clinical trials, including predictive modeling or also doing some exploratory data analysis to see which particular subgroups of patients could benefit more from a treatment. But more and more, we're also using R to actually produce validated outputs that go to regulatory entities within validated R environments. And we actively pursuing a goal of being able in the future to ship interactive solutions, apps, together with static outputs to the regulatory authorities to actually streamline the process of evaluating or also approving a drug or a treatment. I'm here today to show you an example of one of these apps as we use them. This particular one we used throughout a couple of different COVID-19 studies that we had running or which are still running. We use a Shiny solution powered by an internal framework which we call Nest, which features some nice aspects. So especially, it's totally modularizable. It's quite data agnostic, so you can use like an app scaffold and just swap out the data from different studies. It features some really nice live filtering. And this allows for some flexible exploratory data analysis with these reusable modules for plots and tables, also efficacy outputs. It's all parameterizable via templates. So these templates take care of updating the inputs and setting the correct filters, which helps a lot with reproducibility. And once you have like the outputs you desire, you can create a quick report which is just HTML based, editable, and flexible, stylable with CSS. I'll show you a quick video of an example app using some dummy data. This is the typical scaffold as you would see it, with some different tabs having different modules. So one for a table, one for line plot, box plots, but also efficacy outputs like your Kaplan-Meier curves, your time to event analysis. It features this filtering panel on the right-hand side, so you can filter the different data sets that are generated for clinical trials with different types of data, lab data, patient-level data. And via drop-down menus, you can select which variable you want to filter at, and then interactively set the filters you want to use. And on the left-hand side, you have this template drop-down menu, which is pre-populated study specifically with some templates that you might want to use, but you can also add your own templates, or rather one that has been generated by somebody else, and just copy-paste it, apply it, and it will automatically update the filters and set the correct inputs. Once you hit the run button, it will generate the output that you pre-specified now. So in this example, a line plot. And one particularity is actually that every time you hit the run button, it will create you a new output in these new cards, so you can generate multiple outputs and compare them side by side. Also, in this example, it gives you an additional table with some descriptive statistics. And once you have the desired output, you can star it and favorite it because you want to keep it, and discharge the ones that you actually don't want to. Then you can also move to another tab, for example, here a table module, and you can create whatever table you want. You also give it a star. You switch over to the reporting module, where you can add your favorites to the report. So we pull all of these favorited starred outputs into this one module, where you then can update titles or add some notes, and also arrange a little bit the order, how you want your report to be generated, and then click on Open Report, and it will render you a report in HTML, which is still editable, so you can still change your notes or change your titles. And this one can then be saved as a PDF for sharing. All of these modules and these reports also, they record necessary information, for example, what filters have been set, what inputs or what methods have been used, so you can really have some kind of reproducibility, or at least like it's well documented what you have done. This is it so far for a quick glimpse of how we use R at Roche. I thank you very much for your attention and wish you a good rest of the conference. Have a good day. Thank you.
So we thank Roche
so far for a quick glimpse of how we use R at Roche. I thank you very much for your attention and wish you a good rest of the conference.
Sorry about that, folks. Just hearing a bit of the video again. So we thank Roche for sharing that presentation with us to share a little bit of how they're using R. And now it's my pleasure to introduce our keynote speaker, Jeroen Ooms. Jeroen is a researcher and software developer with R OpenSci at the University of California, Berkeley. He has written many CRAN packages and also maintains the compilers and build infrastructure for R on Windows. Today, he's going to talk to us about the R Universe project. During his talk, please post messages on the KeyOms Slack channel, that's #key_OOMS, or ask and vote on questions via the Zoom Q&A. Over to you, Jeroen.
Thank you. Let me share my slides. There we go. Are we good? I assume so. All right, thank you so much for having me. So this talk will be about the R Universe project, which is a big, new, ambitious project by R OpenSci, which I've been working on for the past year or longer. In this talk, I will discuss some of the different components and use cases for R Universe. But if you're going to take away one thing from this talk, it should be that R Universe is for everyone. It is a place for publishing research and research software. It can be used by individuals and organizations. It's beneficial to novice R users, to students, researchers, or professional package developers. There's no gatekeeping in R Universe. If you have some R code or R Markdown article that you think is worth sharing, regardless of what it is, you can sign up and start doing that today, no matter your background or expertise. All right, so a little bit about me. My name is Jeroen. I'm a staff research engineer and the lead infrastructure for R OpenSci. If you don't know R OpenSci, we are a research group based at UC Berkeley doing all sorts of things related to open science with R. And if you want to learn more about our group, you should really check out the talk by Stephanie Butland earlier this week, who gives a great overview of our mission and the various activities of R OpenSci. And as part of my work with R OpenSci, I've written quite a few CRAN packages. Most of these packages interface to interesting C and C++ libraries, which expose functionality to R that can be useful for researchers. For example, packages providing interfaces to HTTP clients or cryptography or database drivers or image processing and so on. And finally, as Heather already mentioned, I'm currently also the maintainer of the official installers and toolchains and system libraries for R on Windows. So in this role of Windows maintainer, I spent quite some time in the past few years trying to modernize the infrastructure to build R and the compilers and the system libraries needed by R packages, collectively known as R tools. And so this process is now entirely automated and transparent and reproducible, such that everyone can see how this works and get involved. And at the same time, I really try to redesign R tools to reduce the friction for Windows users to develop R packages on their machine. So these days, if you install R tools 4 and R, things should generally just work, which wasn't always the case. And if you're interested in this work, you should check out the R Windows organization on GitHub. So that was briefly a bit of background about me. Let's talk about R Universe. So what is R Universe? R Universe is sort of an umbrella project under which we are experimenting with many ideas that we have developed at R Open Sci in the past years to take open science with R to the next level. And in essence, R Universe is an open platform for publishing and discovering research and research software written in R. And the platform has many features and different components. But the core is that in R Universe, everybody, every user or organization has a personal CRAN-like package repository, which is backed by a modern build system and also allows you to publish articles and other R-based content. And on top of that, R Universe has extensive dashboards and feeds and APIs and metrics and so on to make all of this content more openly available and accessible and discoverable. So how does it work? In a nutshell, so in R Universe, every user or organization has a unique subdomain under runiverse.dev for publishing their content. And this subdomain is mapped to your GitHub account name. So it can either be an individual account or a team account from GitHub. So for example, I publish my personal content under jeroen.ropensci.dev, and things that I develop as part of R Open Sci go under ropensci.runiverse.dev. And so on this subdomain, for every user, you can find a CRAN-like repository with R packages owned by this user or organization. This repository automatically includes binaries for Windows and Mac OS and some of the other things that you expect from a CRAN-like repository. So it works, installing from this repository works for users exactly the same as when they would be installing a package from CRAN. You can also find our Markdown articles published by this user organization and a lot of metadata, which I will show later on. And if you open this domain in the browser, you get a dashboard for visually browsing and exploring the content in this universe, the packages and the articles. But all of the data is also available programmatically using HTTP APIs. Again, as I already said, everything is fully automated. Right, so that might sound like a lot. So let's just look at an example. So here is the ggSeg universe. ggSeg is a suite of R packages that is developed by a research group at the University of Oslo for brain and cognition research. Most packages here are maintained by Athanasia Mowinkle, and currently we see that there's 14 packages in the universe, and one of these packages is on CRAN, and the others are not. So again, the owner of this universe is the ggSeg GitHub account, which is an organization account, and hence the URL of the universe is ggseg.ouruniverse.dev. And through this GitHub account, we can also show some information about this user. So that's what you see on the right. It is the profile picture and information from the ggSeg group that we take from GitHub. Well, the Our Universe dashboard that you get when you browse, when you go to this subdomain in the browser, has a few tabs through which you can browse the different sorts of content in the universe. So I'll walk a little bit through that. And by the way, as we develop this, and if you may be watching this thing in the future, there might be additional tabs, or they may have different names. But the idea will remain the same. So first, let's look at the most core thing, which are the packages. So the builds tab is its first tab, and it shows an overview of recently updated packages in this universe, and that shows the version and the maintainer and the date of the most recent commit to the package. And it also shows this green badge when the package is available from CRAN. And on top of that, on the top of the page, we show some example code for users to explain how to install a package from this universe in R. So users can directly copy paste that code into their R session and start using these packages from this universe. So just like CRAN, we automatically build binaries for Windows and macOS for the current and previous release of R. So that is this column with Windows and macOS icons that shows if there is a binary package available for Windows and Mac, which in this case is true for each of the packages. The color of this icon shows if the package also passes all of the CMD checks. So if the icon is green, it means that the package was successfully built and deployed, and it also passes CMD check. And if the icon is gray, in this case, it means that the package was successfully built and deployed to our universe, but there was some error or warning in CMD check. So it means that the users can still install this package, but maybe if you're the maintainer, you might want to look at what's going on. So as said, the top of the page shows example code of how you could install packages from this universe. So this is a CRAN-like repository, so it's simply using install.packages. The easiest way is by setting the repos argument in R to both your universe and then also CRAN. So what happens with this code is that the package and its dependencies will be installed from the ggSeg universe. But for dependencies of the package that are not available from ggSeg, it will fall back on CRAN. So note that, again, all of this is done using the base R package manager, exactly as when the user would install from CRAN. And on Windows and Mac, we have these binary packages. So the user does not need any complicated tools and libraries to build these things from source. All right, so the second tab of the dashboard is called Packages. And this basically gives us an overview of the content of the packages that are in the universe. So this is just mostly information that is taken from description files and then some additional metadata that we collect when a package is deployed. So for example, it includes the title and the description for all of the packages in the universe, who is the maintainer and the most recent commit. So this is like a cool, like a place where you can quickly browse like what is available from this universe and what it is. And if the package has a logo, this is also shown here in this dashboard. So there's a few standard places where you can include the logo into your package, and we use the same rules as package down to find the logo. So if the logo works for package down, it will show up here as well. So yeah, so this tab shows you some of the information from our database that we have for packages, but there's really much more available through the APIs. So this is basically just the core stuff that's interesting to visually inspect. But as I will show later, so this dashboard actually calls to exactly the same API that's also public. So we don't cheat. And you can look at these APIs to extract many more pieces of information from the packages that are deployed in the universe. All right, so that was everything about packages. Let's talk a little bit about articles. So besides publishing packages, our universe is specifically intended as a place for publishing articles. And this is really articles in the broad sense. These can be vignettes with documentation, but they may also be research or like, you know, a tutorial or anything that you think is worth sharing. Yeah, so if you go to this third tab, you can see a list of all of the articles that are available for this user or organization. And they are listed here. And these are automatically rendered using the vignette system in R. So the idea is that you include these articles into an R package, and then they automatically get built and rendered and shown here in the dashboard. However, articles don't have to be limited to software documentation. So I will emphasize it a bit later on, but really you can publish any sorts of content in your rmarkdown article. So it can be a research paper or a tutorial or a homework assignment. Yeah, so whatever you want to publish into your universe. So you can easily browse these articles within the dashboard by clicking on them from the list that I just shown, and this will show the article within the context of this dashboard. So it's easy to sort of browse through the different articles in the universe, or maybe across different universes. And all of these articles are rendered in a consistent HTML theme, and that is the same across all universes. So hopefully that makes it more pleasant to browse rather than, you know, when all of these are using their own theme, as you see on CRAN. Yeah, so you can browse these articles from within the dashboard, but the top of the articles also show direct links to the input markdown file and the output file. So you can link to these resources directly if you just want to share the HTML or the rmarkdown without people having to go to the dashboard. All right, API access. So an important feature of our universe is also that we provide programmatic access to all of the content and the metadata that is in the system. So I think this is an important part of open science, that content is not, locked away in some platform, but, made accessible and available in as many generic ways as possible. So all of the information that I've shown so far in the dashboard, you can retrieve that through APIs, and you can even retrieve much more information and also sort of aggregate statistics and other sort of meta information about the repository and the system through our APIs. The API tab shows a few of these example endpoints that you can explore if you think that's interesting. So this part is still a bit under development, although the endpoints that I've documented here are pretty stable. So you can play with this in your browser or in R. So for example, the dash packages endpoint in this slide provides all of the information and all of the data that we have for a given version of a given package. So in this URL dash packages dash slash ggseg slash and then the version number, it lists all of the artifacts and the data that we have for this version of this package. So in this case, it's listing, it would list probably a list with 5 artifacts into a JSON list, which is 1 source package and 2 binary packages for Windows and 2 binary packages for Mac OS. And then this API call shows all of the data that we have about these files, about these package artifacts. And of course, you can also read all of this in R or any other language or platform that understands HTTP or JSON. So I'll leave it up to you to run this code. One thing to note is that many endpoints in our universe use the ND-JSON format, which is a streaming version of JSON, which is needed for to optimize performance. And therefore, if you want to read these aggregate endpoints in R, mostly under dash stats, you need to use the stream in function in JSON Lite or the equivalent function to read ND-JSON format from your favorite JSON library. Right, so that was sort of a very brief tour of what we have so far. So let's take one step back. So for who is our universe intended? It's like, why are we building this? So I think there are many different use cases of having a personal art publishing space for your personal work or your organization or research group. So the system is built around the concept of packages, of course, as the central container and deployment format, but it's certainly not only for professional or package developers. So in your universe, you can publish whatever you want. There's no policy, there's no policing of what is allowed or not, and there's certainly no archiving happening without your approval. So yes, I will show in a bit. You can use it to publish dev versions of CRAN packages for sure, but you can also think about publishing, more experimental projects or research material or even homework assignments. So let's have a look at some examples of the early adopters of users and organizations that are currently using this system. So one example is that you can simply use it as sort of your personal package portfolio. So suppose you've written a bunch of R packages, some of which may be on CRAN or they may be in various places on Git. And you can set up a universe to showcase all of your work. It will sort of show everyone like things you've developed and if they're in good state and what you're currently working on and so on. And also, for example, if you publish articles, you can use it to have sort of a collection of things you've written about R or your research. Another use case is to use a universe as an outlet for your research group. So here's an example of a research group based at the Imperial College in London, and they develop a suite of packages that is mostly maintained by Rich Fitzjohn. And many of these packages may not be suitable for CRAN, or it's just too much of a pain to release it all on CRAN. So they release all of their source code on GitHub. But by creating a universe, you can sort of increase the exposure to the work and sort of make it more accessible and discoverable for the users, rather than when it's only available in source form somewhere on a GitHub account that people may not be aware of. Another use case for our universe is software curation. So, as you may know, the R OpenSci organization maintains a large suite of peer-reviewed and staff-maintained R packages, for which we try to keep up to standard for use in scientific research. So this is actually where our universe originates from, this idea. So through the R OpenSci universe, it becomes easy to see for users which packages are available, and it's easy for them to install, regardless of whether or not they are on CRAN or not at that point. But it also helps us as an organization, as a monitoring tool. So from the dashboard and the APIs, we can keep an eye on the development activity of the packages that live in our organization, and we can quickly spot packages that are failing tests, or they don't seem to be actively maintained anymore, and they might require our attention. And another use case of our universe is simply to publish the development versions of CRAN packages. So sometimes users, they may want to test a version of a package that is not yet on CRAN to test some new feature or a bug fix. Installing packages from source from GitHub sometimes can be quite painful, because many of these packages from rlib, for example, they contain C++ code, or they require system libraries, and so on. So by creating a universe for this, everything gets automatically built, and it's very easy for users to install the development version of the package. It's just as easy if they would install the CRAN version of that package without requiring any special tools or knowledge. Yeah. And finally, another example of a use case is for organizations that are developing an interdependent set of R packages in a given domain, such as, for example, here, the R spatial organization, who develop a set of R packages that are all related to geospatial analysis. So if in the universe you can quickly see what they're currently working on and try the latest versions of these packages. And a benefit for the developers of these packages is that these packages automatically get built and tested against the other versions of the packages in the universe. So these are the other dev versions of the packages in the universe. So if one of the maintainers of these packages makes a change that unknowingly breaks some of the other packages that depend on that, it quickly becomes apparent in this dashboard, because the other packages are built and checked against the version of this of the dependencies that are in this same universe. So you can quickly see if the package that is being developed is passing checks in the content of the current development versions of its dependencies, without having to do a manual revdep check before the CRAN release, and then figuring out that you broke something a long time ago and having to go back. So these are just some of the examples. There's many more examples. We have about 300 universes right now. You can browse our webpage to see some of the cool stuff what's in there. But I want to highlight one more use case, which I'm personally most excited about, that we haven't seen much yet. So we are used to think of R packages mostly for sharing reusable code. I mean, that is what CRAN is for. It's to share software that is useful for other people. But many researchers have argued that an R package is actually a fantastic generic container format for research material. R packages provide standard format for bundling code and data and articles, and metadata such as the author and the license and dependencies and so on. You could think that, for example, if you have a publication or a homework assignment which consists of a rmarkdown article or a SWI file, and then you have some supporting code and data, and you can you have that in a set up in a reproducible project or something. From here, it's actually a small step to put it into an R package and publish that into your personal universe so that you get a live automatically rendered version of that paper or that assignment on your R universe. Yeah, this idea has been raised in the past by various people, but it never took off. And I think because, well, sure, you could put your research into an R package, but then what? I mean, this can't go on CRAN because it's not software. So, what are you accomplishing? But I hope that maybe now, if you have your personal CRAN-like repositories and your vignettes are sort of beautifully rendered, this idea can take off and people can. It becomes really rewarding to turn your research paper into an R package that is entirely fully reproducible and automatic, such that the vignette contains your paper or your article, and it through the supporting code in the package and the data in the package and the dependencies that are declared in your package file. We have this place of publishing like fully automated reproducible research. All right, so that was an overview of different use cases that we envision. So far we've mostly looked at single universes, but we want visitors of the website to be able to quickly discover and browse content from various universes. So one way is through these global feeds. So if you go through the R Universe homepage, we show a global feed of all package commits across all universes. So that's fun to look at, to sort of see what people are working on across the entire R ecosystem. Similarly, we have a feed for articles, so you can see which articles have recently been created or updated across the entire ecosystem. So this actually works very well. It's very cool. I've discovered several cool new R packages and new features just by looking at what people are writing in their articles. And finally, there's a maintainer view on the website, which shows an aggregate of all the people, so the maintainers of these packages across all of the different universes. So, for example, if you hover on a certain name of a author, you may see that this author has published or maintaining packages in several universes, and then you sort of may cross-link, and you click on that and sort of see the different groups that they're working on and different projects. All right, so maybe by now you're curious, how do I set up my own universe? I promise it's very simple. I will briefly show how it works in the upcoming minutes, but the best reference for this is a tech note that we wrote recently on the R OpenSci blog, which you can check out on ropensci.org. But basically the way it works is all we need from you is a registry file, which is a file called packages.json. and it lists the packages that you want to include in your universe. It has to list the name of the package and the URL, the Git URL from where we can Git clone that package. And the only requirement is that this URL is a public Git URL. So from here, our build service will literally Git clone and that URL. And that's basically everything you need to provide. So you need to publish that in a repository called universe in the GitHub user or organization for which you want to create a universe. For example, here is the one by Mael. And then the next step is to activate this by installing the GitHub app on your account for which you want to create the universe. And the GitHub app needs very few permissions. It basically only asks for writing commit status updates, which means that the system is able to post like a commit status, which is like the green check mark or the red cross behind your commit on the R package repositories, as we will see in a second. So once you've done this, what happens next is that the system automatically creates a monorepo for you. Again, there's another blog post which extensively describes this process, so you don't have to remember it. But basically, the monorepo is a Git repository in which each of your packages is a submodule. And this is basically the canonical source for your universe. And it allows us to see currently, but also have a full history of what was in your universe at any given point in time. And then if you go to the Actions tab of this monorepo on GitHub, which is, by the way, all of the monorepos are under r-universe / and the name of your account. And there you can see where all the building happens. So if something is not working or you're just curious, you can check that out. And then once you've set it up, after a while, usually no more than an hour, packages that have complete building will start appearing on your dashboard. And then if you gave it permission, if you gave the GitHub app permission to write commit statuses, as I said earlier, then every time a package is successfully deployed on your R universe, it becomes visible in the R package repository, as you see here, as a commit status. So that is as a link here with a green check mark. So that means that this commit for this package was successfully deployed onto our universe. All right, so this is basically the current state. So this is what we have right now. We have just started this and we really want to build it out. We have many ideas for features we want to have. But one thing that we are working on and that I want to highlight is that we want to integrate various metrics about packages that may be good indicators about the quality and the health and the impact of research projects. So if you want to understand the motivation behind this better, you can watch the recording from my talk at our Studio Conf from earlier this year. The link is also on our homepage. And in the talk, I try to explain why we believe it is important for organizations and potential users of software to get a sense of the health and the quality of the software that they build on. And in this talk, I talk a bit about various types of indicators that I think that you could look at for an open source project. And here I distinguish technical and social and scientific indicators that may say something about the health and the role and the impact of a project. So we want to integrate such indicators with our universe, such that the dashboard and the API show some information about these software and research projects that give you a sense if the project is still active and how it is maintained, and if it is used by other researchers and so on. So for example, some low-hanging fruit, we want to show something about the download statistics and the reverse dependencies of packages that are obviously a indicator of how much something is used, and particularly, for example, if we look at these numbers over time, you may get a sense about the life cycle of the package, if this is something that's sort of up and coming or on its way out, or sort of an established package into the ecosystem. But a much more challenging and important aspect of this project is to find uses and citations of research software in scientific code and publications. And we think this is very important for research software to be able to say, like, where is this software used in, in actual scientific research. So for this, we are collaborating with a team of experts to build machine learning models to recognize software mentions in the literature. And they are now running experiments to look at the citations from like a large corpus of 20 or 30 million open access articles and try to extract citations automatically, especially for software that we haven't seen before. So we hope to announce some interesting progress in this area later this year. Right, so that was most of what I had to say. Small recap. So what is R-Universe and why is it useful? So it's an open platform for publishing research and research software and other R-based content. The system automatically tracks your Git repositories and then builds the binaries and the articles and so on. Users can easily install these things just like they can from CRAN. There's no complex tools needed like R tools or remotes or so on. Installation for users is just like as they would install from CRAN. And then the dashboards, they show the R packages and the articles that you have published. And they can even work when the actual source content is spread across different GitHub organizations or even different Git servers. Also, R-Universe can be used as a zero configuration continuous integration system. So as I showed, if you give the app permission, it will show this check mark when the package was successfully deployed. So if you want to have a continuous integration, or actually it's continuous deployment in this case, for your R packages, you can just install that app and there's no other maintenance or configuration on your site, and it will just run so the standard checks on a different platform, so you can quickly spot if there's an issue. And yeah, R-Universe is very easy to set up. We've tried to deal with all of the challenges, solve that on our server side. So really what you need is just provide a list of the Git repositories that you want to include. So we hope that it sort of becomes a space where you can publish your content, your packages and your articles, maybe other things later. That is both, these packages can also both be on GitHub or they can also be on CRAN. It doesn't have to be exclusive. And again, I want to emphasize R-Universe can be used by anyone, whether you are just starting to use R or you are a veteran package developer. You can set up your own universe and start publishing your work. So some references, if you want to learn more, I recommend you check out our website from rOpenSci, where we have a landing page for the project. And in particular, so documentation for R-Universe is a little bit sparse right now, but the best references are a few tech notes that we published on the blog. So for example, we have a post that is entirely dedicated to explaining how the build system works, and one in which I have explained the idea of publishing articles based on the vignette system, and also this idea of, what if we could use this system not just to publish software documentation, but actually to start publish like research compendia and other research material that would not be suitable on CRAN, but definitely fits into an R package. And then there is the most recent blog post in which I detail how you go about setting up your own R universe and some of the tricks if you want more fine control. Yeah, that was everything I had to say. Thank you so much for listening.
Thanks so much, Jeroen. Yeah, so we've got 10 minutes for questions, and we have lots of questions on the Q&A and also on the Slack. So we probably won't be able to get to them all, but we'll see what we can do now. So to start with, how do you guard against malware and so on in our universe?
We don't. So the idea is that it's your personal publishing space. I expect that users will install, so they will, if they install something from a particular universe, just as if they would install software directly from GitHub using install with GitHub or something that you think about, right, from that you install that from sources that you trust. And yeah, so in a sense it is, and it is similar to when users would install from GitHub, is that you need to trust the source of the author or the organization from where you are installing this from.
Okay. Does our universe build macOS binary packages the same way CRAN does? In other words, can we use our universe like a win builder to predict CRAN's success of building binaries for macOS?
Mostly yes. I mean, CRAN is not. It's unclear exactly how CRAN builds things because their build platform is not entirely open. But in most cases, I would say if the package builds on our universe, it will probably work on CRAN, vice versa. But it's impossible to exactly replicate the configuration of the Mac build server because we are building everything in public CI service on GitHub. So obviously we don't know all of the custom settings and tweaks that they may have, that CRAN may have configured on their build server. Okay,
makes sense. Perhaps while we're on building, are there plans to also build Linux binaries in the future, e.g. for selected distributions similar to RSPM?
Maybe, but not right now, because it's pretty resource intensive to orchestrate that, and of course our studio is doing that for their for CRAN, and they have a lot of resources to be able to build these binaries. But it's very expensive because if you want to build Linux binaries, you need to build separate binaries for every version of R for every different version of every different operating system. So you literally need a binary for R 4.0 for Ubuntu 20, and then another binary for R 4.0 for Ubuntu 80 and so forth. And that so it's like you need to build a lot of things. So for now that is out of scope, and it doesn't weigh up to the price that would cost us to provide these things.
And which version on GitHub gets built? Is it the latest commit on master?
You can specify that. So this is detailed in the blog post about how to set up your own universe. By default, it will be tracking the head branch, which is the default Git branch, which is either master or main. But you can specify in your registry file if you want which branch you want to track. So, for example, if you have a special stable branch where you only commit things that you want to share that are considered stable in your registry file, you can track that. And there's even a special value that you can enter in your branch called star release, which is a syntax that we taken from remotes. And if you track that, it will automatically track the latest GitHub release of the package. So in GitHub, you can tag releases of your package. And if you specify in your registry file, you want to track the star release branch, then we know that at any point we look like what is the latest git tag, what is the latest tagged release on GitHub, and that's what will be deployed in your universe. So it's really, the control is at the user.
And can we build something like this on private clouds, or does it require GitHub?
It does not require GitHub, but private is pretty complicated. I've also written about this in the last tech note. The R packages, the source code of the packages, they may be hosted on any Git server. So they may be hosted on GitHub, but they may also be hosted on GitLab, or they may be hosted on like a private Git server by your university or your institution. The only thing that matters is that is public, and we can Git clone from that URL the source code of your package. Making this private is pretty complicated, and I don't think that we are very interested in that right now, because we are about open science. And if we would make this private, it would add like layers of authentication and complexity at every level. You know, we would have to authenticate probably. We're pulling the source code, and then I imagine you would expect users to authenticate if they want to install the package, which I think ours install the packages doesn't even support authentication. So that is really not something that we are at this point investing in.
If I install something from our universe, is the R package rm able to know that it's installed from there when I create a snapshot?
Yes. The description file, as you install the package, of course, the description file of the package is installed, and that one contains several fields which we stamp, which our build server stamp into the description file, which shows you which universe repository this package was installed from. And it also shows you for the package that's built, it shows you the upstream URL of the R package, so the Git URL of the package where you built from, and it shows you which branch that this package was installed from. So by default, that's master or main, but if you're installing from something else, and it shows you the SHA hash of which version of the package was built. So if you look at the description file of the installed package, you will be able to see exactly like which universe it is coming from, and also which commit to the R package that this package was built of.
Okay. Can a package be part of multiple universes?
Yes, absolutely. That we see that happening a lot. So the universe registry file, you just list the Git URLs from the packages you want to include, and of course, different people may all include the same package. You know, for example, if you have I may have a package of mine that's both part of OpenSci and it's also part of my personal universe. That's fine.
Can our universe be used to share forks of CRAN packages, say?
So that's, you can, but it's tricky. And so we specifically, of course, that's dangerous, right? So because I mean, of course you can share a fork of a package, and you can even share a completely different package with the same name. But of course, that is not something we would recommend, because then if the user installs that, then it overrides the other package, and maybe other packages on your system were depending on that package. So then things break. So in the dashboard, we will show indicators like these badges on whether the package also exists on CRAN. And then if it is the same source as the package from CRAN. So we will show actually a red flag if the package has the same name as a package that is on CRAN, but the URL does not match what is shown on CRAN. And thereby we try to show, we try to warn users or also developers against, like, watch out, because this package has the same name as a CRAN package, but it may actually not be from the same source.
Thanks so much for rattling through those questions. There's still a few more left, and hopefully you'll be able to follow up with those afterwards on Slack, on Key Ooms channel. Up next, we have a 15-minute break and 3 parallel sessions after that. Statistics and bioinformatics are in production, and statistical modelling and data analysis. So join us there. Thanks very much, everyone.